folks streaming in. I'll give it a couple of minutes. I appreciate top of the hour, everyone's grabbing their teas, coffees, beverages of choice. So we are all super excited to see you. I'm really excited today. We've got Shane doing the hard work. I'm just doing the hosting today. This is great. So Shane will break down the full details of lessons from putting AI in front of a platform. And if you are interested, of course, we have launched Syntasso Kratix Agentic. So if you're interested in learning more, pop along to that website. Shane will do a little sort of intro overview of the new product at the end, and I can always answer any questions along the way. So chuck into your platform of choice any questions you've got around this. But we're super excited. We're seeing a lot of love for AI and agents within platforms. We've got some thoughts. We've got some opinions. We're never short of opinions at Syntasso, I'll tell you that. And Shane is going to share some of his today as well. So I think we're looking pretty good, Shane. I see folks rolling in. If I remove that banner from you and put your stuff in front of everyone, I think we're ready to rock and roll, Shane, if you're good.
Yeah, let's do it. All right.
I'll disappear off and I'll see everyone again in a minute. But welcome, Shane.
All right. Thanks, Daniel. What a lovely intro. But hello, everyone. Thanks for joining. My name's Shane. And today I'm going to talk about some lessons I learned putting AI in front of a platform. And the TLDR of it all really is that like AI can become incredibly useful when platforms sort of turn that like fuzzy AI intention into validated actions. And I'll explain much more about this later. Before that, a little bit about me. I'm Shane. I'm an engineering manager at Syntasso. We work on Kratix, which is an open source framework for building platforms. I also co-host Hybrid Cloud Show, which is a podcast where we talk about the public cloud, private cloud, and everything in between. And I also write a monthly platform engineering newsletter. So do check those out. The reason I mention Kratix up front is that it's the platform I've used for an AI bake-off that I'll show later on in this webinar. But the lesson's kind of broader than Kratix. It is like about what happens when AIs meet a proper platform interface. All right. So to get into it, the mental model I want to kind of share here is deliberately simple, which is AI is autocomplete. Maybe that's not new, but I think it's something we may have forgotten a little bit over the last while when it's gotten really impressive. Like, I know it feels far from just an autocomplete right now. In coding terms, it's not just auto-completing functions like based on local context, which is what GitHub Copilot used to do in the early days of when AI kind of started. It's doing so much more, but fundamentally, it is still just a very, very good autocomplete. It's not magic. It's not sentient. It's not a tiny engineer living in the machine. It's a prediction engine choosing from a huge space of possible completions. And I find it a very helpful way to frame when I'm building or interacting with AI systems that is how it works. The circle on this slide is kind of meant to represent like that possibility space, everything the AI might plausibly say or do next. And when the circle is huge, there's lots of valid looking ways to be wrong, which I think we've all probably experienced. So the question for the rest of this talk, or one of them to try to answer, is like, how do we make that circle smaller? And reliable AI, despite what the AI companies might say, isn't just about better models. It's about reducing the plausible wrong answers that an AI can access. So I think maybe in the earlier days as well, like the naive assumption might have been that like, if AI gets something wrong, we should just give it more context. It might be more documentation, examples, repos, more runbooks, more tokens, just burn more cash. Basically, our CEO jokes that we're going to all be paid in tokens in the future, which is a terrifying thought, but more context should help, right? If I ask, sometimes it helps, I would say, actually. More context sometimes help. If I ask a general question to an AI about shoes and then give the model some context about running shoes, I've narrowed down that possibility space and it's much more likely to autocomplete into the world of shoes, right? Not Kubernetes or tax law or sourdough recipes. But more context isn't necessarily better context. Imagine asking someone for directions, and instead of giving them just a clean map, you give them the current map, 3 old maps, tourist guides, a list of roadworks from last year, and some handwritten shortcuts from someone who used to live there. You've narrowed down the problem to this city, but you've also given them many more plausible but convincing routes to choose from, including ones that are out of date or unofficial or just wrong, basically. And that's what happens with AI. If we give it raw Kubernetes docs, old runbooks, outdated examples, half-remembered conventions. They all give the model like more to complete from, and the answer might sound more locally informed, but it can also become more plausibly wrong. If you think about that cities example, like, so you could ask a person with that context, hey, give me a route from A to B, and they will give you a list of directions, and those street names will look convincing. These sound like street names in the city I'm in, but they might be from street names from 60 years ago. But that's kind of what AI is fumbling with to try to get you an answer. And so the goal isn't to feed AI everything. The goal is to make most wrong completions unreachable to the AI. So this is sort of the key mental model to kind of think about, right? A raw model has a huge possibility space. Anything goes. Instructions and skills can kind of narrow the space by making good behavior more likely, but they are still guidance. It could be an agent's MD file or a skills MD file or some other docs that it needs to follow. But we're basically saying, like, please work this way, and it may not. It just may choose to do something wild and wonderful, which again, I think we've all experienced. Platform tools narrow it down further because the AI can only call the operations exposed by the platform, which is good, right? But the final step is a bit different, and why it's shaped differently here is there's a deterministic API contract. So to take an example, like an MCP would give a model a way to call tools, but the API contract is the type checker. It'll check required fields, it'll check allowed values, it'll check like validation rules and like rejection paths. So the model is probabilistic. No matter how small that circle gets, there's still uncertainty there. There's still like probabilistic behavior. The platform API isn't, right? That's hard line at the end that the API or the AI needs to interact with, right? So the model can suggest, but the API contract is what decides what is valid. So how do kind of platforms help here? And I think this slide shows the platform kind of doing two jobs. For people building platforms, the platform kind of exposes enough surface area to build and evolve the platform for an AI. So effectively, you're building to a contract you're going to offer to your consumers, and you're going to be bound by that contract. You're going to abstract away everything behind that contract, whatever that is. Maybe you like offer Redis as a service. You're going to have explicit arguments you're going to want and arguments you're not going to offer. There's going to be defaults that you're going to force. And for consumers, the circle's smaller, right? The platform is going to expose a much smaller surface area. It's going to be a clear abstraction that a human consumer or an AI consumer can use. The consumer doesn't need to know about like which Kubernetes resources get created. They don't need to know how credentials are generated, what like labels are required for like tagging resources, or what like network policies need to look like. This is all, the platform will collapse all of that into sort of a very small intentional interface. And that interface is really useful for humans, but it's critical for AI because AI doesn't reliably respect implicit organizational boundaries. A human might know that payments goes through a service request and a review, but an AI will only know that if the boundary is encoded in the contract. We'll talk a little bit more about this in general, but the summary is like this: consumer is going to describe intent and the platform owns the implementation. Next slide here. Cool. So the bake-off. All right. I kind of wanted to test a little bit of this theory around these kind of like possibility spaces. So we have two agents here set up with two very different contexts. It's going to be the same model, same prompt, same desired outcome. Imagine you're an engineer at a company. The payments team, maybe you're part of the payments team, and you need a production Postgres database, and you've been handed an AI system to make it happen. It's not too far off the realms of possibility that this could be our future, right? We just get a ask and an AI prompt. So agent A is going to get raw Kubernetes access, and agent B is going to get a Kratix promise interface. And so just for context, a Kratix promise is the platform contract for something as a service. So it defines what a consumer can ask for, what fields are required, and then how the platform turns that request into infrastructure. So it could be small, like Postgres as a service. Give me a database with this size and owner and tier and cost center, or it can be much larger, like an app as a service. Give me a deployable app with standard CI/CD, observability, ingress secrets, what have you. Or it could be broader again, like the environment as a service. Could be, give me a whole deployment for production, or a preview environment with the right apps, databases, policies, and access controls all wired together. The point is that the consumer asks for an outcome and the platform owns the implementation. So taking it back to our AI, right? The question is not going to be which AI is smarter. It's which operating surface we put in front of the same AI gets better outcomes. So again, you're an engineer at your company. Payments team needs a Postgres database, and you've been handed this AI assistant. This is the exact prompt that I'm going to give to agents. Same task, same model, same desired outcome. Notice though what the prompt is not saying. It's not saying about backups or network policy or labels or status, etc. Right? And that's deliberate. That's because those are platform concerns, not developer trying to add new features to the payment system. So the test isn't going to be like whether or not an AI can make something that runs. It almost certainly will. The test is whether the AI can produce something that satisfies the organization's definition of what a good platform provisions database should look like. But before we judge the result, we probably need to define what good looks like here, right? Again, if the only question is, did it create a database? I'm almost certain any agent would probably do that right now. But the platform is supposed to give us more than a running resource. So it should give us things like API first contracts, discoverability, self-service. It should have declarative requests, observability, guardrails. So this is the bar that I've set for the bake-off. And I think it's a good definition of what a pretty good platform should have. But the key line is this, right? An agent can succeed at provisioning and still fail this bar. So, right. I should give some context. This slide is my evidence. I am not doing a live demo because the last time I did a webinar and did a live demo with Claude, it broke right as I was doing the demo in weird and wonderful ways that made it not obvious Claude was down and just looked like my demo was broken and really shoddy. And then after the webinar, Claude's status page finally said, yeah, we're actually down. But my reputational damage had already taken the hit. So I'm not taking that risk again. Sorry. So this is going to be my receipt and evidence that I did run an actual bake-off. The setup was pretty simple, right? I had an AI agent that ran the same prompt against two different sub-agents running in two different local kind Kubernetes clusters. The key difference was what was running in both of those clusters effectively. One had, as I said, that raw Kubernetes style access through kubectl and a Kubernetes MCP server, and the other had the Kratix promise interface. And again, it had quite a lot of promises in there. It was like a fully fleshed out like platform with a bunch of capabilities people can request. So after I served the request, I then interrogated the outputs. Well, what have you built now, basically, is what I asked. And then I compared that against the platform bar. Agent A, which we'll call kind of the vibey sort of like, creating things on the fly agent, created the database successfully. It did it with Kubernetes primitives. The database ran. I even verified it with the PostgreSQL CLI. Agent B found the Postgres promise and request interface. It requested details about what are the types of information I can ask of this database. It worked out, okay, I can use this Kratix promise capability to fulfill the ask of me, which was that previous prompt. And then it generated that request and then submitted that request to Kratix. And the platform then generated and reconciled those lower level resources. So Agent B wasn't manually building any infrastructure. It just used the platform capability that fulfilled that developer's request. So this is the evidence behind the next scorecard I'm going to give you. So we're going to score those two agents against the platform bar. And let's start by being fair to Agent A, the vibey agent. It did ship a working Postgres database, and I did verify it, right? But the scorecard wasn't asking, did Postgres run? It's asking whether the results met a standard of platform engineering we're happy with. So in terms of like for API first, Agent A failed because it produced ad hoc YAML. It built Kubernetes resources directly, but there was no type platform. It wasn't something you could reuse. It was just all the values are hard coded everywhere. Agent B passed because it just used the Kratix Postgres promises and API. So the API is there and it didn't recreate a new one. It was just, in terms of discoverability, Agent A kind of guessed the shape from general Kubernetes knowledge, which is absolutely fair. That's the context we've given it. It's taken that huge possibility space, it's taken that ask, and then generated what it could do to the best of its ability. Agent B inspected the schema that the Kratix promise had provided before it acted, so it knew what a platform-supported request was supposed to look like. So it did its discovery, found the thing it needed, decided that thing it needed could be fulfilled by this, and made the request. Both passed in terms of self-service, both built and delivered end-to-end results without a human actually having to manually step in. So credit to Agent A there. In terms of declarative, Agent A got partial credit. It did produce everything in YAML, which is great, but it then decided to create secrets imperatively. So it made some API requests instead. And even then, it only created one secret value, which was the database password, which, might be fine if all the other secrets weren't secret, which they weren't. It was like the other values it needed might have been like host or port or database name. But maybe you work at a company where all of these types of configurations should be set as secret. So Agent B submitted the intent to Kratix. It submitted the values that this promise needed, which were owner, cost center, tier, and size, which are all things that were needed from the prompt. And the platform then handled the implementation. So the platform created secret held the full connection shape, that host, DB name, password, etc. So it knew to encode everything into secrets. In terms of idempotency, again, Agent A failed because rerunning would have conflicted and generated a different secret. Everything would have broken. That meant the second run for Agent A would have meant it's not safely converging on that declared state. Agent B passed because the same request could have been reapplied continually effectively, and it would have given the same results. In terms of safe upgrades, Agent A, this was an interesting one. Agent A kind of got partial credit because it used stateful sets, which just by luck give you kind of some useful Kubernetes defaults. They'll give you a stable identity, persistent volumes, and sort of ordered rolling updates, which is great. I don't know if it shows that intentionally or not, but let's give it the benefit of the doubt. It's definitely better than like randomly creating a database pod with an empty disk. But it's not the same as like a platform-owned database upgrade strategy. It doesn't encode backup policy or compatibility checks or migration rules or rollbacks or approvals, etc. So Agent B basically got the platform pipeline and reconciliation path that the platform provided. So upgrades were owned by the platform, not invented by the AI. In terms of observability, Agent A kind of generated some loose labels. Again, it didn't know what patterns to apply, so it just kind of made its own up. Had no durable request objects, no platform audit. Agent B got like standard label, status, and a long-lived request object that it could query, interrogate, and get the state of. So it got like long life observability for this resource that's requested. Again, in terms of guardrails, Agent A failed. It gave itself a lot of broad access. It didn't create a network policy. So in practical terms, what that might have meant is the database was running, but the network boundary wouldn't have been encoded in the platform. So depending on the cluster networking setup, a bunch of stuff that shouldn't have accessed this database would have accessed it. Agent B got scoped access. There was guardrails. It had a network policy. So it was all well locked down. So that was a lot of words. Effectively, both agents shipped a database, but only one shipped one that you'd be proud of or feel safe managing under a platform. And so taking a step back here from this, if we're looking at this pattern, this producer-consumer pattern through like infrastructure and DevOps and platform engineering, but I think the same producer-consumer pattern and problem kind of applies much more broadly across companies. So the Bake Off really showed like the problem in one space. The idea of like a large possibility space and small possibility space and how you can get better outcomes. But this was for like just a simple database request. But I think the same problem exists between teams in general in organizations. Every unclear team boundary is kind of like another possibility space. A platform team just happens to be an obvious producer. It's kind of exposing infrastructure capabilities for other teams to consume. But platform teams aren't the only producers. There's like data teams, or payments teams, or identity teams, or I guess like DevX maybe even. And any team that's exposing a capability to someone is a producer, which has consumers. AI makes those like producer-consumer contracts much harder to leave implicit. Humans can kind of work around all these unclear boundaries. They can ask the right person, they can read a Slack thread, they can pick up culture. But AI won't do that reliably. It'll happily complete from whatever context it can see, even if that context is old or now culturally forbidden or only true in one part of a company. Like, the question is not which team owns a capability. The question is whether that team exposes a clear service contract that a human or an AI can safely consume. And a lot of organizations are running on this informal collaboration. It's Slack threads, it's pub conversations. Ask Jenny, she knows. And a lot of culture enforced boundaries. That works surprisingly well for humans. Before platform engineering was a thing, that was how infrastructure was done. It was through DevOps. It was very ad hoc. Humans kind of absorb that culture, infer boundaries, will ask follow-up questions. AI won't. It doesn't know who Jenny is. It doesn't know that the payment service is not supposed to be touched directly. It doesn't know that a runbook might be technically true but culturally forbidden now. So AI needs X as a service. It needs a published interface, a defined contract, guardrails, observable outcomes. The short version of this is basically humans can absorb culture. AI needs explicit producer-consumer contracts. Or even shorter, like humans can ask a Jenny, AI needs an API. So, and the message here is not that every team needs to become a platform team. I might feel like I'm pitching it that way, but it's not. The message is that every producer capability needs an explicit service contract. That might be a Kratix promise for infrastructure, or might be an internal API for payments, might be a data product, could be a DevX workflow. The pattern is the same. The producer owns a capability, the consumer uses a clear interface. The contract defines what's valid, and the implementation stays behind that boundary. You don't leak into it. It's where AIs cross those boundaries that, here be dragons. And that's why platforms become even more relevant with AI. Platform engineers have been building these contracts for years. We've been making kind of messy operational reality consumable through these stable interfaces. And AI makes that discipline useful kind of everywhere. And so the moral is, like, don't turn everyone into a platform team, but turn every producer capability into something that can be safely consumed as a service. Or try to think about your organization as a set of consumers and producers. And how can you be more explicit about those definitions so that either a human will benefit from it, but an AI will also hugely benefit from it. And so kind of the final, maybe practical question is, like, how do you even know this is working? Let's say you've sort of decided, yes, I kind of like want to think about things like a probability space. Like, how do I know, like, if I'm working with an AI system to build something, or I'm working with an AI, a system that's going to be consumed by an AI? Like, how do I know it's working? How do I know whether it's getting better? Well, you kind of need to track whether the circle is shrinking, right? Deterministic APIs will reduce the chance of breaking boundaries, which is really important. AI can still do the wrong thing with a valid API. It could request the wrong size or the wrong tier, the wrong capability. That prompt I showed earlier on, it may have said, oh, okay, this Postgres promise doesn't actually fulfill what I need. I'm going to make my own. So it could try to do its own thing. So how do you kind of work out whether it's like giving you the right outcomes or not? And you kind of need benchmarks and evals that measure whether the AI is getting closer to your desired platform outcome or further away. And that's what that bake-off kind of was that it showed, right? It's a small platform eval. Did the agent use the API? Did it discover the schema? Did it stay declarative? Was it idempotent? Were status, labels, guardrails preserved? You can kind of build a small suite of these scenarios and kind of run them regularly. If the same prompt produces more consistent, contracted here results over time, you're kind of winning. That's the aim. If a model change, a platform change, a prompt change, or a tool change even makes the AI more variable, the circle's grown. And that's a regression. That's the way you should treat it. The metric isn't going to be, did it produce YAML? Did it make a database? It's going to be, did the metric stay inside the contract? So practically speaking, what does this kind of mean? Well, version your prompts, I think, is a good start. Like, version your platform configuration, like version a lot of like things which you may not have versioned in the past or not have thought to version in the past, because effectively you're going to try to track these things over time, and everything is text, so it's quite nice that you can kind of like visualize the world. You want to run an eval suite after any meaningful changes you make. Again, and it might not even be changes you make. It may be Claude is certainly updated to a new model. You always pull the latest model, and suddenly it's started exhibiting behavior that's surprising, right? So yeah, run the eval suite after those meaningful changes. Track your contract adherence and when there's variance. If the AI surprises you, always treat that as a bug. Maybe the prompt's wrong. Maybe the contract's unclear. Maybe the tool exposes too much. maybe the platform abstraction is too leaky. That's something I've noticed a lot, like in platform teams, where you kind of have a pretty good platform in front of you, but you're still reliant on certain leaky abstractions that humans can kind of like through culture kind of absorb and manage well, but maybe an AI won't anymore. So I'd love to think about those things. But the important thing is don't treat it as magic, right? Treat it as a signal that the possibility space is, again, too large. So that kind of brings us to Syntasso Kratix Agentic. And I think the way I'd kind of describe it in the language of this talk is like AI operating through Kratix platform contracts, not around them. It's not some AI bolted onto Kubernetes. It's not giving an agent a shell and kind of hoping it behaves. It's an AI using platform contracts, guardrails, and abstractions as the operating surface. So that's what it gives you. Remember that like pre-collapse possibility space? That's given to you by design. And the platform decides what's valid. The promises kind of define the interface, the pipeline alone, the implementation, and the AI works inside that boundary, whether it's building promises or it's consuming them. And that's kind of the difference between like an impressive demo and something that you can like trust in front of real infrastructure and not be afraid to own and manage long term. Cool. So wrapping up, AI is just an autocomplete. That's gonna be controversial, I think, but AI just autocomplete over a possibility space. More context does not automatically make that space smaller. Platforms help because they expose constrained, discoverable, deterministic contracts. And this isn't just an infrastructure lesson. Every producer-consumer relationship in an organization needs clearer contracts. A model can suggest the API is what decides what is valid. And I think that's it. Yeah, that's the talk. Thank you all so much for listening. If you want more details, feel free to check out that blog post that is in that QR code there, or feel free to ask questions or reach out on this LinkedIn if we don't have any time.